All right, so we got some new software, and I think this might help the issue with the technology. So we're going to go ahead and finish the 1.3 section that we were working on yesterday for college algebra here. So bear with me as I work with this new software just a little bit here, but we got 1.3 is our section. So we're working on some word problems. Simple interest is the first one. That's going to be I. So interest is going to equal principal times rate times time in years. So one example here is of one investment you have through a summer job. Morgan is able to save $2,500. She puts that money into a 6-month certificate of deposit, otherwise known as a CD, that pays simple interest of 3.5% per year. How much will she have at the end of 6 months? So let's see here. We have our principal is going to be the original amount invested. That's going to be a $2,500. Our rate is going to be 3.5%, but as a decimal, so as a decimal, we're going to move that over 2 places to the left. So it's going to be a 0.035. And then time, this is in years, so 6 months in years is 0.5. So our interest on that is going to be principal times rate times time. So we're going to go 2,500 times 0.035 times 0.5. Okay, so let's grab a calculator. I want to see if this works with a calculator. So where is that calculator? There it is. All right, so our calculator, we're going to go 2,500 times 0.035 times 0.5. That's going to give us $43.75. All right, so our interest is going to be $43.75. And then we're going to add that to the 2,500 she already has because we want to know how much money she has total in the account. So if we add those together, we are going to have $2,543.75. Okay, so the next one is a little bit more complicated because we have 2 different accounts here. So we have, let's see, we have $2,400 and we decide to invest the money in 2 different investments, one paying 18%, the other paying 12%. And then 1 year later, we have $27,480 in our account. How much did we originally invest? Okay, so what we have here is X is going to be the amount that we invest at 18%. And then whatever's left, that's going to be the amount invested at 12%. We have 2 different rates, 18% and 12%. So what I want to do here, oops, thought I was still on the link here, undo, oh, there it is. Okay, so what I want to do here is I actually want to set up a system of equations, kind of do this a little bit differently. Okay, so it's going to come to this part, but I want to see how you get there. So first we're going to have the amount. So we know that some amount X plus some amount Y is going to equal that $24,000. Okay, we split that into 2 different amounts. It could be half and half. It could not be. We don't know. But it's 2 different amounts. And let's say the amount that we invested here for X, that was at the 18%. So we're going to say that's going to be 0.18X. So 18% is a decimal. And then the other amount we invested in the 12%. So that's going to be the 0.12Y. And we had a year later $27,480. So the interest is what we earned. So the interest is, let's see, $2,780 minus $24,000. 27. Oh, I missed a 4 there. 2,748. There you go. 24,000 is, what is that? $3,480. Okay, so that's 3,000. Keep wanting to forget that $480. So that's the amount of interest earned. So once we do that, where's my calculator here? Just want to check my quick math there. Yeah, 3,480. Okay, so once we do that, then we have a system of equations. So now you can do substitution or you can do elimination for this system here. So let's say I do substitution. That's where this amount, this comes in here. So let's say I do this x plus y equals 24,000. I subtract the x, I get y equals 24,000 minus x. So I'm going to take that 24,000 minus x, I'm going to substitute it into my second equation right here for that y value. So I'm going to have, let's go a different color here. So I'm going to have 0.18 x plus 0.12, and then that's my y. So my y is 24,000 minus x, and that is going to equal 3,480. Okay, let me, there we go. Okay, a little easier to see there for me. So still getting used, this is a same tablet, just different software that I'm writing on here. So this is first time I'm using it. Okay, so then we're going to work this out. So we're going to go 0.18 x plus, so we go 0.12 times 2,400. Let me go ahead and get that calculator. That was 2880. And then minus 0.12x equals 3480. All right, so we'll want to combine like terms. 0.18x minus 0.12x, that's going to give us 0.06x. And we'll bring this down. Okay, then we'll subtract the 2880. There's a little bit of a lag. Let's see. All right, so we're going to get 0.06x, 3480 minus 2880. I wish I could pull up the calculator with this. I think I might be able to. Hold on a sec. Maybe if I pull it over this way. Ooh, there we go. Cool. But then once I write on it, it'll probably go away. So 3480 minus 2880 gives us 600. Yep, it went bye-bye. And then we're going to divide by 0.06. So that is going to give us 600 divided by 0.06. It should be 10,000. All right, so we get 10,000. That's going to be the amount invested in X. And what we did before, that was the 0.18 here. So the X, I ignored all of this here. So the X is 10,000 invested at 18%. And then the Y is that left over. So there's 24,000 total. So Y is just 24,000 minus what we had here. So that would be 14,000. So 14,000 was invested at the 12%. All right, let's take a look at the next page. Let me zoom in a bit. So this is where we have a work together problem. Okay, so let's look at this. We have, and I'm going to move this over here. There we go. So we can look, maybe zoom in one more. Okay, so here we go. So we have Joe can paint a house alone in 12 hours and working by himself, it takes Bob 8 hours. How long would it take if they work together? So here's the trick to these. You look at how long it takes them per hour. So if Joe does it in 12 hours, Bob does it in 8 hours. Here's a trick. Joe can do 1/12 of the job per hour. Bob can do 1/8 of the job per hour. How much can they do per hour if they work together? So the way that you would want to set this up is your fractions here. So if you look at this, if you add their labor, 1/12 plus 1/8 equals 1 over the time it would take them together. Okay, so that would give you, if you worked this out, 4.8 hours, if we went through that. So I'm going to show you how to do this. All right, so it's 1 over one person's rate, 1 over the other person's rate, and then 1 over together. That is your formula here for your work together problems. Here we go. So here you have, it's Sally and Lex take 5 hours together. Alone, it takes Lex 15 hours. How long does it take Sally alone? So here's the formula. You have 1 over person 1. So we're going to make that Sally. Plus 1 over person 2. So that's Lex. Equals 1 over working them together. So plug in what we know. Okay, we know that it takes them, let's see, it's 5 hours together, so that's going to go right here for the together. Lex is 15, so 1 over 15 for Lex, and then our unknown is Sally. So Sally, the unknown, gets the X. Well, now we have an equation to work with, so we're going to go ahead and do that. So there's a couple different ways we can do this. We can add on this side, find a common denominator, and then cross multiply, or we can clear the fractions. So let's go ahead, let's clear the fractions. So we're going to find an LCD here, and that LCD we're going to go, let's see, 15 and 5 both go into 30. And then we need an X. So we're going to multiply everything by 30X. Okay, so these X's are going to cancel. That's going to give you a 30. Let's see, 15 goes into 30 2 times. Software is lagging. I'm not sure if I'm liking it. It might just be because my battery's dying. All right, so 1 times 2 is going to be 2x here. And then 5 goes into 30 6 times. So that gives you a 6x. So now we have an equation to solve. We're going to subtract the 2x from both sides. That's going to give us, let's see, 30 equals 4x. Now we're going to divide by 4, and we're going to get 7.5. Okay. Yeah, 7.5. So it takes Sally 7.5 hours to do the web page alone. Okay, let's take a look at the next one. You have James and Carl. Okay, so let's see, James is 15 hours to paint the house alone. So that's going to be, we're going to go 1 over James. And then Carl, 1 over Carl. And then 1 over together. I'm just going to abbreviate that. All right, so we have James is 15. And Carl is 12. 1 over together. Okay, so that'll be your X. So we're going to add these together and then cross multiply. So if we want to add these two fractions together, you could also clear the denominators here if you want, but I'm just going with different methods. Actually, let me show you guys how to do this in your calculator. Hold on. Let me pull over the calculator again. All right, so we're going to pull this over. So if you just add 1/15 plus 1/12, use parentheses, 1 divided by 15, close the parentheses, plus open parentheses, 1 over 12, close parentheses. Okay, you're going to get 0.15, but let's say we want to keep that as a fraction. You're going to go to this button here. This is math, and then that's convert to a fraction. So enter, enter. You're going to get 3 over 20. Okay, so we're going to add those together. That gives us 3 over 20 equals 1 over x, and then cross multiply. So 3 times x gives us 3x. 20 times 1 gives us 20. And then we're going to divide by 3. So let's see here. 20 divided by 3 gives us 6 repeating. So 6.6 repeating. Or we could say, what is that? 6 2/3. So it takes them 6 2/3 hours together. And that is painting a house. Painting a house here. Okay, so let's look at literal equations. Okay, this is where we're solving for a specific variable here. So all you're doing when you're solving for a specific variable is you're really just rearranging the equation so that a specific variable is by itself. So you're not actually solving anything, and I think that's where people sometimes get confused. So here you're just rearranging. Okay, you're just rearranging an equation. Using opposite operations. Okay, so here you have your solving for Q. So I'm just going to write this a little bit bigger. So C plus QR. So if I'm solving here for my Q, okay, I am going to start with what's furthest away on this side, which is that C. It's a positive C. So if I were to move it to the other side, I'd do the opposite of this. This is plus C, so I'm going to minus C from both sides. Okay, now C minus C will be 0, so it cancels out. A minus C you cannot do, so you write them next to each other like that. And then you have Q, R. So that's Q times R. So you're going to do the opposite of times here, which is divide. So you're going to divide by R, and then you have to do that on this side. R. Okay, then R divided by R cancels, and Q is by itself. So that's it. A minus C over R. Next one's a little more complicated because D appears twice. So for this one, what we're going to want to do, let's see here. Okay, so since it appears twice here, you want to isolate it where you can. So it's already isolated. So take it out as a GCF. So if I divide this whole thing by D, it comes like this, T minus Y. Now I'm not doing that on both sides. Okay, the reason why is because I didn't actually change the face of this equation at all. All I did was take this out. If I distributed it, I'd be right back here. So it hasn't changed at all. That's why I'm not doing it on both sides. So you can take out a GCF just on one side. And then you want to isolate the D. Now this is D times T minus Y. So if you divide by T minus Y, then the D will be by itself. And that's it for this one. And one thing I want to make a note of, if this is a capital A to start and these are lowercase, that's how you would want to keep them in your homework. All right, so I'm going to end this video. For the practice problems, I am going to make new videos. So look out for that video as well.